Hello, everyone. This is Sergio Caltagirone, Vice President of Threat Intelligence at Dragos. Joining me this evening is Mr. Rob Lee, and we're going to discuss some awesome stuff around threat detection strategies, a really, I think, important topic that doesn't get nearly sufficient coverage or attention. We talk about detection a lot. We talk about different maybe types of detection, even a little bit in terms of their things, but early on, finding the right to detection. And there's no one right way to do it, and you need to find the right. Fundamentally, we'll try to we're going to try to detect threats, of course, before they create a tremendous amount of impact for organizations. And this is a fundamental issue when it comes to the ability to build a modern enterprise in an assume breach world. Next, Liz. So the NIST Cybersecurity Framework, gives us 5 key areas of attention to building a cybersecurity practice. Of course, though, that we can put a lot of energy into identification and protection of our assets, but as we've learned through the last 30 odd years plus on how we defend our networks, we realize very quickly that the adversary is going to get in, and that's an unfortunate case, but it's one that I think most defenders have now come to realize is a fact of the matter, and that if there is no silver bullet in protection, right? There's no one way to protect yourself, and of course we have things like the top 10 controls, and some do the top 20 controls, and we have compliance frameworks that we can apply to help ensure that best practices are being followed. But fundamentally, we have a very big issue with that adversaries are still getting into environments. And of course, when we talk about going up to a nations and state adversaries at that level, the amount of investment being placed into compromising networks is so large that defending against an organization of that size and caliber is daunting. And in fact, it's probably unfair for most organizations to think they can defend against a state power. But we have to try. And so the fundamental issue here is that detection is the most important thing you do. And while we may try our best, of course, to keep the number of breaches small and to keep them as short as possible, fundamentally, if we want to protect, fundamentally the key of an assuming breach world is that things are going to get in, and that when they get in, we keep them as short as possible, right? So we respond and recover as quickly as possible. Fundamentally, reducing the dwell time of any threat, whether that's a human threat, driven by the keyboard, like as we would say in the term, use the term APT, or whether it's a commodity threat, and it's going to hang out in our networks, and maybe it's warmable and it's trying to move around. In either case, whether we're talking about like high end or low end commodity to APT threats, detecting, responding, and recovering are the 3 fundamental elements to reducing the damage in an environment quickly. Now, I don't want to, of course, say that to the detriment of identifying protection. Of course, good things like, continuity of operations plans and backup strategies and things like that are, of course, valuable. So please don't think that I'm saying you can throw all the rest out the window. You can't. But just realize that that in an assume breach world, that detection does become the most important element of a security operation. Next. So, what we're now going to talk about are detection strategies. And this is one that doesn't get, like I said earlier, this does not get a lot of attention. A detection strategy really focuses not just on what you're going to do, right? It's not the boxes you're going to use that you're going to plug into your network. It's not going to be the host agents you're going to deploy. It's more than the implementation of any one tool or set of tools. And that's really important to realize, and that a lot of people, when they go after detection, they really think in terms of a single box or something like that. And while yes, there's certainly ways of approaching that, using like I would say a vendor first or technology first approach. What every defender needs to do is take a detection strategy approach, which is figure out what you need to do first before you go after how you're going to try to implement it. And so what I like to say is that it's not just the how that matters, right? It's also where you detect and what are you detecting for. And I think that gets lost by a lot of folks. When we think of detection, right, a lot of times all we've thought in terms of detection has been alerts, right? Alerts that feed a SOC, that generate tickets, that go move through a queue, that get triaged, and boxes get rebuilt, and maybe SOC level 2 or 3 gets involved, and it becomes a much more serious incident, and all of a sudden you've got all these people getting called in on a weekend, and it's not a great day for anyone, right? And that's all great, but realize that there's so much more to detection than that one scenario that honestly gets almost all the attention. So, the other thing we need to realize is that not just how, when, and where are you going to detect, but also realizing that part of that is a resource question, that you don't have all of the resources in the world. And so there are two elements here. First of all, not every resource in your environment needs to have the same level of detection applied. One fundamental issue we've had with a lot of organizations is that they thought that they've had to apply the same level of detection to every asset, right? So they plug in a box and it covers everything, or they put out an agent and it goes to every box, and they don't realize that detection, just like prevention and protection, just like the earlier stages of the NIST cybersecurity framework, you have to do some sort of resource triaging. And to say that, hey, maybe certain assets need additional levels of protection, and maybe certain assets don't need certain levels of protection. I know several enterprises who are going through a zero trust model right now on their endpoints, and every endpoint on the environment is simply just getting standard Windows AV on their host, and the enterprise doesn't care at all about anything else going on the host. And so they're treating every host in their environment, every endpoint, user endpoint, I should say, every user endpoint effectively as an internet user, right? They don't trust you at all. You can be compromised all day long. They're not going to expend SOC resources on you. And so there are several organizations, really large organizations, moving to this model because they realize that they can't protect 100,000 endpoint users now anymore effectively. And so they're going to pull their resources, right, these security operations resources back deeper into the enterprise to protect more of what's most important. And many organizations are moving that route and towards that paradigm. I think in total, I think we're seeing a major cost of security operations and effectively the cost of detection, right? So when you have bad detection and bad alerts, then we're going to have then you're going to increase the cost of your security operations. And then, of course, the fact is that, like I said, detection is multi-use. And so I'm sorry about the audio breaking up there. And so I'll do my best, I guess. So the detection is multi-use, and meaning that we don't just we don't just detect for alerts. So we may run detection to support operations. To support investigations. So that would be, again, SOC level 2 and 3. I mean, many of you on the call may have been involved in some serious incidents, and you'll realize very quickly that when you are, your security operations teams will deploy additional detection around a specific incident in order to do the scoping and remediation necessary, right, to understand the threat, to understand the environment and what's going on. And so, in an industrial environment, we're going to talk about how, controllers and HMIs, engineering workstations are all different types of assets. And they'll all require slightly different levels of protection. And so that's an implementation in how we would see such an approach in an OT environment. Next. So how would you go about doing this? So what I like to say is generate detection targets. This is an approach I've taken before in my career, and it's worked out fairly well. And the thing is, you don't have to be complete, right? The goal is not to be complete, because the fact of the matter is, if you do it well enough, you'll achieve really good coverage. We're never going to be perfect, and we should honestly not strive for perfection in detection, because, I think that's a wasted strategy in and of itself. But fundamentally, if you do this task well enough, then you'll get we'll talk about quality in a little bit, but the fundamental issue here is you'll get good enough. And so what we first do is we go to what our most important assets in an environment are, and realize that this is not in terms of our value, right? We need to think in terms of what is the value to our business operations and our industrial processes. So the fact is that, there are certain things in our environment that we should be okay to lose that will not significantly impact the environment. And so the assets, right, you're going to start listing the assets based on the importance to your particular process and business outcome. And so here we have our assets. We list different events that can happen to each asset that we're interested in. We also list the location of which we could detect detect that event on that asset. And so you can detect it in more than one place. Host, network, logs, things like that are all appropriate. Of course, you have process, output, and historian data that you can leverage as well. Use cases, right? So this is now, what type of detection are you attempting to use? Or what are you trying to go after? So for instance, novel attacks. Right? Are you trying to find new ways that nobody ever thought of before, or any defender has considered detecting before? So adversaries that are doing things brand new, or are you looking for similar type attacks to ones that we already know about? And then, of course, there's another use case. We'll walk through more of these, but scoping, right? So the fact is, when something happens, maybe we need to scope an event. That how many, right, is this happening to? How often is this happening? When did it start? These are all good scoping questions. And these happen, and these are generally supporting post-breach, post-detection response and remediation. And then lastly, detection types. So we're going to talk about the 4 types of detection: behavioral, behavioral, modeling, indicator-based approach, and so forth. We'll go through those. Rob will hit those here in a second. But the fact is that, we can also list multiple types of detection that we're going to use to achieve something. So, so basically you're going to get a fairly long list here. And it's important to do, next slide, Liz, to then put these into what I like to call the detection map. And now this is very similar to something that you may have seen if you're familiar with the kill chain paper. There's a kind of an element to that in the paper, but here, right, what we're doing is we're placing on our left side we're placing the Purdue model levels on the left side, and then we're placing the kill chain stages across the top. And, the fundamental question here is, for each one of these events that we've listed, whether these are against engineering workstations or VPNs or controllers or HMIs or what have you in there, the question is, what's our confidence in detecting that event against that asset? And so here, I like to suggest using a simple traffic light kind of approach. Red meaning there's no confidence that you could. Yellow meaning there's some confidence, and then green meaning strong confidence that you could detect that. And this should give you now a target to go and engineer and implement against, and then lastly to test against, right? That you could have a blue team approach or a red team approach here and go after these and see if you could actually do it. And of course, events, real world compromises would, of course, give you some of the testing data as well. Unfortunately, not in the best case scenario, but it does happen. And those should obviously, you know, as a defender, you use every data point you possibly can. So next. Yeah. So now I'm going to hand it off to Mr. Rob Lee, and then I'll come back later and go through a use case scenario with everyone to show how you might lay out such a strategy.
Yeah, perfect. Thanks, Sergio. And really, the 4 types of detection as the subject of this webinar is based off of the paper that Sergio and I wrote as well. You can download, and really, it came down to he and I sitting around thinking over a couple cold beverages about what would we really need to think about in terms of strategies? Like, how would they differ? How can we cluster the different detection types? And at the end of the day, it really fell into these 4 different types of detection as the overarching approaches that you can take. Now, you can take a lot of subtypes to them. I'll go over a few in a second. But really, we thought of how is the detection occurring, not the data type leading into it. Sometimes I see people mix up what is going into the detection, like host versus network versus log, versus like what you're actually trying to accomplish. The how can be innovated a number of different ways, but the what are we doing is very fundamental to that strategy. So as an example, you know, the first type of detection, and we'll walk through each of these separately over slides as well, but the first type of detection is configuration analysis. It's effectively the find Waldo type approach, right? It's the whitelist styled approach of measuring what we call newness. So you're looking for anything new in that environment. So you have your current configuration, whether it's on a host, on an ICS, you know, process, on a network traffic, whatever it is, you have what's occurring today, and then some new thing occurring. And so the good thing about configuration analysis is it's going to technically catch everything. The downside is that it's going to detect everything. Anything new in your environment will be discovered, and the adversary eventually has to do something new to do something malicious. So it will work, but it's probably not. Well, we'll get into this, but it's not exactly the best way to go about your business because it generates a lot of data, but it does have a use. All 4 types end up having really important uses, and kind of the pitch at the end is that you really should look to doing all 4. Just understand the pros and cons of each. But the evolution of configuration analysis was this idea of don't show me everything new. Show me the new stuff that's interesting or anomalous or weird in my environment. And that was the idea of taking effectively the baseline and then adding a threshold and time component to it. So it's often done with a mathematical type model. You can do it manually. We see a lot of machine learning based approaches. Usually when you hear people using machine learning or similar approaches, they're talking about modeling. It's this idea that I'm going to build a model of your environment, which is here's what normal looks like. And so it's that baseline plus some acceptable threshold. And then there's a time component to it. Maybe, you know, 5, maybe a logic change in the control environment is okay, but 4 to 5 times in a single day that's not in a maintenance window that I see logic changes, that might be anomalous for my environment. It might be weird. So it bakes in, if you will, that model to your environment. The good aspect of that is you're now highlighting changes that are more interesting out of configuration analysis. The downside to that effectively is there's no context of the threat that you're looking at. Both modeling and configuration analysis are environmental based. So I don't need to know anything about the threats. I'm basing the detection off of changes in my environment. So in the third type would be indicators. That's your first threat type of detection, or based off of threats, I should say, for detection. And indicators are a lot more far-reaching than just indicators of compromise. So that's really what a lot of people think of with indicators, but you need data and context effectively can be an indicator. But an indicator largely would be those static and atomic type values, maybe an IP address, a digital hash, specific mutex and malware. And the value of indicators is effectively they can contain maximum context. That IP address at that point in time was leveraged by that adversary. There's a lot of context that gets contained inside of that individual indicator. The downside, of course, with indicators is they don't really scale that well. The ability to share indicators across folks getting targeted by an adversary, it's not actually very effective. I would say majority of indicators end up being victim specific, but they do have a lot of context in them. So in the same way that modeling was an evolution of configuration analysis, threat behaviors ends up being an evolution of indicators, which is saying, how can I maintain as much context as possible, but not be bound now to specific data points? So threat behavior might say, VPN into a human machine interface that drops a new file and then RDPs out is a behavior that's been associated with a SCADA hijack scenario. Actually, that one's pretty equivalent with the Ukraine 2015 attack. And so at a high level, I'm not looking for technical data. I'm not looking for the hash of the file. I'm not looking for the IP address, the VPN, or the RDP session. I'm looking for a series of events, but I know what I'm looking for at that series of events. I have the context of where that malicious behavior has been seen before. And so at the end of the day, all four types of detection theoretically can detect the same thing. Like all four could be used to detect an attack. Ukraine 2015 or Ukraine 2016 or whatever scenario you want to throw. In hindsight, you could leverage any of them to say, oh yeah, I could have detected with that. But that's not necessarily the most effective or efficient way to go about your job. And so we have to think about those pros and cons. So that's what we'll do now. When we hit to the next slide, we'll start breaking down each of these types. So from a configuration-based perspective, I have another example there where two field devices are communicating to each other. And in the architecture and the design, we expect those two PLCs not to be communicating directly with each other. We wouldn't expect like a PLC to be talking to another PLC in most industries. Some of you might have that, always edge cases in industrial. But I wouldn't expect like a Modbus session between two PLCs, or I wouldn't expect an SSH session between two PLCs. So if they're talking on the network already, but they're both communicating to the HMI, and then all of a sudden those two PLCs start communicating to each other, obviously that's a new thing in my environment. So the benefits of being able to detect that are pretty numerous. I mean, I could potentially get perfect visibility with configuration-based detection if I roll it out in the maximum way and I actually have newness across all my environment. Technically, I could have perfect visibility across that environment. And it's fairly easy to maintain in static environments. Actually rolling out a configuration-based approach, it can be fairly simple. It might be challenging because of architecture and product choices. But as far as technical expertise of the system itself or of the threats, it's both pretty low. I don't really need to know a lot about the system, and I don't really need to know about a lot about the threats. I just need to know anything that new changes, I want to know about it. The downside, of course, to configuration-based detection is also numerous. First of which is it is difficult to maintain in dynamic environments. I think a lot of people outside the ICS community, the first time they see industrial environments, they think, oh, wow, this is a super static environment. And that's simply not true. It is more static in some ways than an enterprise network. Don't have a lot of YouTube and Facebook-based traffic on HMIs normally. There's not as many user kind of connections, but there is still a lot of things happening in that industrial environment, especially when we consider beyond the network into the industrial process itself. It's actually fairly dynamic. So you'll get a lot of configuration changes still. The other aspect, of course, is you do need to have enough understanding of your infrastructure to make sure you already have good visibility across everything. So I say you could hypothetically get perfect visibility without knowing what that visibility should be. You'll never fully be in that position. And the biggest challenge, of course, is it's a ton of false positives. From a threat detection perspective, there's going to be an inordinate amount of configuration-based detections that happen on a day-to-day basis. Next slide. From a modeling-based perspective, I think we see this one in the market the most of kind of the anomaly detection systems. I actually think they can provide a lot of value, but there's a lot of cons with how they're being used today as well, being stepped through. So in this case, I wrote that the abnormal number of write requests in Modbus TCP. So maybe I expect to see write requests at a Modbus TCP. My machine learning model bakes in, models the communication to those controllers and says, hey, this is abnormal. number of write requests for what we're expecting. So the benefits in that is pretty awesome at first. The identification of novel adversary activity. I think a lot of anomaly detection gets pitched for finding the unknown unknowns, saying that we can detect completely novel activity, which is kind of true, kind of false. I think it's true enough. You can absolutely detect novel activity, but you don't really know what it is. You'll see a weird write command to a safety system, but you don't have enough information to actually take action on it. But it's true that you did detect it from generating an alert perspective. But what I really like about modeling-based detection, what I think it adds most value, is it's a significant value to other detection types. So if I know that I have a modification in SIS, and I already know it's malicious, like I am using either an indicator or a threat behavior-based approach, and I say, yep, this is a malicious action taking place, and then I also have an anomaly or a modeling-based detection in the data historian, well, then I might know that there was a physical process impact from that detection. So it's actually great for kind of layering on top of other detections. The challenges with modeling or I would say from my career doing incident response kind of intel work, kind of the things that have not resonated with me about modeling-based detections is first and foremost is it is difficult to maintain. No matter how static you think that environment is, it's not perfectly static. So you are forever tuning that system. You bake it in the beginning over a couple of days, couple of weeks, potentially. I think most of the vendors say you can do it in an hour, but they generally want a couple of weeks of bake-in period. But after that bake-in period, you are forever tuning that system and making sure that what's going on is correct. The downside, of course, as well is its limited visibility. So the model is baked in that environment, and it's that specific environment. You can't really transfer it to another environment. But when it alerts, you don't really know why it alerted. It says, hey, it's a abnormal number of write requests, but it tends to be kind of that black box on the network. It is an interesting data source, but it is still just a data source. And then, of course, the other thing that I would caution people on is a modeling-based detection, especially anomaly kind of detection. You're going to generate still a lot of alerts. And one way that people try to sort of tune that in is start whitelisting out the alerts and communications that they see as being okay. Say, oh, you know what, the communication SIS is actually fine. That's from the engineer workstation, and that's a whitelisted styled network flow now. The problem is a lot of the industrial attacks we're seeing are actually taking advantage of native functionality, native features in the systems. So you could effectively be whitelisting in functionality that is not being used today maliciously, but is in the future being used maliciously. So modeling-based detection has a number of pros as well, but we do need to be careful of how it's leveraged because it can generate a lot of answers in the data, but you don't necessarily know what the question is that the detection is asking. Next slide, please. From an indicator-based perspective, the benefits is by far the quickest form of detection to create. Once an analyst is sitting in front of adversary behavior or adversary activity, they can look at it and quickly go, oh, okay, there's an IP address, there's a digital hash, quick little bit of malware analysis, there's some key indicators we can extract. So it is very, very quick to create and deploy these types of detections. The downside of that kind of speed is it's also incredibly quick for the adversary to change the value of that detection. The benefit to the defender is completely in the control of the adversary. If they want to stop using that technical data, they can, and you do not know when that switchover occurs. So you could have a lot of legacy indicators in your environment that you're not sure of the value anymore. Again, another benefit, of course, though, is it does contain a lot of context related to that indicator if done correctly. Now, we've all had the threat feeds and indicators that are very meaningless, and people aren't taking advantage of that context. I've seen so many IP addresses that come out and they say, oh, this command and control. Like that's not real context. Like command and control for what? When was it observed? What actually did it communicate to? Did it pull down an implant? Was it being used for exfiltration? Like what is this IP address actually? So you do have to be careful in how you're enriching that data, but it can be a data source with a lot of context in it. Another downside though is if you're just depending off of an indicator-based approach, you're going to be constantly adding more and more indicators. The number of attacks or intrusions that occur in your industry or tangential industries can be so high that there's a kind of computational and analyst limitation. I think most of us that have worked in a SOC at one point or a detection team will fondly and cynically remember having an alert on the system, it being based off an indicator, and everybody looking around each other and going, well, what is that? Like who put that there? When did that actually, what indicator is that? And it ends up generating so many questions instead of answers that you spend more time trying to figure out where the indicator came from than leveraging it for the actual detection. So still, you got to be careful with indicators, but they can be great for the ease of deployment. And we'll get into where that can really help out in the use cases like scoping. Next slide. The threat behavior-based approach, overtly and kind of just to be perfectly transparent, this is the type of approach we take in our own technology and use at Dragos primarily. So we obviously do think highly of this type of approach, but why I think highly of this approach and kind of the pros and cons to be aware of is it allows you to capture the MO or the methods of the adversary without being pigeonholed into the technical data, but it still has enough context and information to help you be effective and efficient in how you're doing detection and response. As an example, here I might say legitimate, VPN access. I kind of gave this one earlier, followed by a user account creation and file download of an engineer workstation. Maybe I have that engineer workstation now logging in that same account, logging into the HMI. In of itself, all of those actions could be completely legitimate. It's all native functionality. I'm not talking about necessarily malicious software being downloaded. Maybe I'm just using PowerShell, which is arguably malware, but I could see completely legitimate things in the environment, but the way that they're being leveraged has been associated with malicious behaviors before. And so this even gets into kind of the fundamental question of what is false positives and true positives. If the behavior is being accurately detected in your environment, I would say that's a good thing. You should be aware of those behaviors in your environment, and the context on top of it is that these have been leveraged maliciously before, so that when you look at it, you're trying to figure out, is it malicious in this context or not? And then you make all the decisions off of it instead of trying to figure out what exactly you're looking at. So the benefits, so the first big one for me that I particularly like is that it's durable against adversary change. If an adversary changes the command and control server that they're using in a campaign, it's going to completely destroy the value of your indicators. But if I'm looking, if I sort of look at how the command and control is being done, maybe in a Profinet-based environment in a manufacturing sector, I'm still using DNS. Profinet can store a lot of information in DNS. So maybe have an internal DNS server in the manufacturing environment, and it's being modified to let exfiltration sort of go out of that environment. Instead of focusing on the technical details, I can focus on the how. How did they modify that? How did they leverage DNS inside of an ICS to do exfiltration? And the adversary can try to change what they're doing all they want, but we are creatures of pattern. Humans are very resistant to how they do things. It's easy to say, okay, let me take a different color car, but how you drive, kind of car choices you make, the routes you take to work, that type of behavior is much more durable. And so one of the benefits of having that durability is you can detect things that haven't occurred yet. You can detect novel novel attacks. You're not detecting novel tradecraft at that point because you do have to document it. It's very much an intelligence-driven approach of here's things we've seen before, but the way those things are being used and how they're being used against different environments is not necessarily just detecting things after the fact. As an example, we tracked 2 different threats this past year that were targeting the electric sector off of completely different nation state kind of profiles. We don't do attribution here, but it was very clear that it was different malware choices, different kind of personas. Everything about the campaigns were different. It was very clearly 2 different teams. But the way they were breaking into the industrial environment and taking information off of HMIs out of the electric sector, the TDPs, if you will, the tradecraft, the behavior was identical. And so the detection of one actually led to the detection of the other as well. Now, the downside of that, of course, is it is moderately difficult to implement. You do need to have people that are really sharp on things like intelligence to go out and observe and do things like intrusion analysis to figure out what the behaviors are of adversaries and codify it into a reliable detection mechanism inside the environment, which means there's a lot of testing. If you deploy a machine learning-based model, you're baking it in. But if you're deploying a threat behavior-based approach, somebody has to be creating these correlations. Somebody actually has to go and do the intrusion analysis, think of what the adversary is actually doing, create the correlation, test it out on test data. Like it is an onerous approach. But another challenge with it is you can't just create one analytic or one behavior in that category. I see now a lot of organizations doing like the MITRE ATT&CK-based framework. And I think it's actually a great tool to get people thinking past indicators and more into tactics, techniques, and procedures of adversaries, more of their tradecraft. But one of the downside I see is people are using it as effectively a scorecard where they go through and say, oh, okay, we have a detection for lateral movement. Well, there's dozens, if not hundreds of ways to do lateral movement. So one detection for that is not going to be sufficient. You do have to have a layered kind of detection strategy when you do that. Another benefit, though, of threat behaviors is where the other types of detection are not really transposable. Like you can't really take the configuration of my environment and give it to you and have it be useful for you in detection. In the same way the indicators lack durability or transposability, the same way that modeling lacks that, it's just difficult to transfer to someone else. But a threat behavior-based approach is extremely transferable. Like I can tell you how the attack occurred, and you can immediately leverage that. You don't have to actually have knowledge of my specific environment. It's just knowledge built up the adversary, and it's durable against the adversary, so it's worth sharing. Now, the other downside, of course, is you absolutely do run into issues in industries. Like the way that you break into a human-machine interface or an engineering workstation might be the exact same way across multiple industries. But if we think about the Ukraine 2016 attack with the crash override malware, getting a master position on HMI, and then sending IEC 104 protocol communications to the RTUs, to the digital relay, to open up the circuit breaker, to de-energize the substation, that's pretty specific. If I write a threat behavior on how to do that, it's going to work for everybody in the electric transmission industry. It doesn't matter if the adversary changes, malware changes, whatever, that behavior is captured. And you now can detect against all similar styled attacks. But that behavior means nothing for somebody in a process control network of an offshore rig or an oil refinery. It's not going to be relevant. So threat behaviors aren't universal across all industries. There's many of them, especially in the higher level Purdue models, that can be. But the more specific the industrial process, the more specific you'll want to get with an understanding of what types of attacks can occur there. And then, of course, the last thing that I really like about behaviors is because I do have transparency in what's occurring. I do know why the detection is occurring. I can start to pair it with defensive playbooks. And so I can start to say, well, if these types of behaviors are observed in my environment and you validate that it's malicious, go ahead and do these 16 follow-on steps. Or here's the way we validate that threat behavior is malicious on a OSI soft historian versus what we're doing with an Aspen historian. So I can quickly break apart playbooks that pair with those analytics to make for an extremely efficient process that also breaks down that knowledge barrier so that an IT security analyst can actually be effective in ICS security, or the ICS security analyst can start to operate at a next tier level by having kind of that knowledge transfer. Next slide. And of course, these are kind of some of the things we went across, but a probably more simplistic way to look at it is from an analytic properties perspective. As we think of modeling, as we think of threat behaviors, as we think of configuration analysis and indicators, you want to be able to measure them for how they help you in your threat detection strategy. So Sergio and I put forth effectively 5 that we heavily consider. One would be transparency and basically understanding why the detection occurred, which is going to empower your analyst with what they should do about it and effectively why they should care. The durability is what I mentioned with withstanding adversary change. An adversary changes a piece of malware or just rolls another hash. We got to be careful that our detection works with that. Ease of implementation. You would have a perfect detection strategy, but if it can't be rolled out to all of your environments, then you may have a significant gap there. Coverage. In other words, how much detection do you need to be able to detect that type of activity? And then adaptability. In other words, once you do figure out that you want to change something about your detection strategy, how quickly can you change? Because flexibility and adaptability are really key in an evolving threat landscape. I think especially for industrial, I made the point before plenty of times that we have a lot of unknowns in the industrial threat landscape. It's completely why we have an intelligence team here. It helps us figure out what is actually occurring out in the threats in this space. But because there's a lot of unknowns, we need to be adaptable and flexible on how we're approaching this. So next slide. So taking those 5, Sergio and I basically mapped out the different detection types to make a scorecard for you all. It's in the paper as well on how to measure those different characteristics across the different types of detection. As I noted, something like configuration is extremely durable. It's not based off of adversary change at all. It's based off of your environment. And the coverage is great, but the ability to adapt it is extremely poor. Once you kind of have your baseline, it can be very rigid to do so. The ease of implementation and transparency is pretty good, but you're still going to get a lot of false positives, and it might not be the best way to sit there and do detection. You could argue you could detect every attack in Wireshark. It doesn't make it an effective way to go about it. Next down from modeling, I think modeling is really good for coverage. Being able to have a baked-in model that looks across your environment for any anomalous kind of changes, even things like user behavioral analytics. We'll get into modeling as well as kind of a sub-tier, device behavior, protocol behavior, anything that's based off of your environment, even though they have the word behavior in it, that's modeling. You can get really, really good coverage with modeling. The downsides, of course, is they're extremely non-transparent. It is really not as easy to implement as I think it's pitched, because you do have to tune it considerably. And it is absolutely very, very difficult to adapt it over time, especially as your environment changes or the threat landscape changes. From an indicator-based perspective, extremely transparent, extremely easy to implement, extremely non-durable. Probably the worst of all of them in terms of adversary change. An adversary can make very few changes and mess up indicators. And then, as I mentioned, from a threat behavior perspective, it has durability and transparency, but also a lot of adaptability. And I would even say one sort of further to that is that transposable nature is shared across. But it's not a very straightforward implementation. You do have to have smart analysts that know what they're looking at to make these things. Next slide. And then as we think about kind of the threat detection applications themselves, these are just 4 sample use cases. There's a lot more out there. You can sort of choose your own path in life with your requirements, but these are the 4 that I typically think a lot about, which is the ability to do an investigation, think through multiple steps of an adversary's life cycle and be able to follow that investigation. I think sometimes we inappropriately think of attacks as these binary events of either, the attack either occurred or it didn't, instead of all the different steps leading up to the attack. Novel attacks are important. I think that there's much more similar attacks in the industry than novel, but it is important to be able to think about how you detect something that's not known. Similar attack detection, of course, is an important part, and then scoping. Kind of how do you do sort of the post-incident work to scope your environment and figure out the breadth of that incident. So next slide, we can kind of look at how those detections, again, sort of rank against those. From an investigations perspective, I think configuration data on its own is fairly limited. I think it's incredibly useful for like a forensics perspective when coupled with other detection types, but on its own, you don't have enough information to even do the investigation. You don't know exactly what you're looking for. Novel attack detection, technically it's the best because you are detecting anything new in your environment. It has no concept of similar threats though, because you're not really tracking anything related to threats. And then scoping, again, kind of getting in that forensic piece is once I do know what the incident is, my ability to say, okay, the attack happened at 2 o'clock on Tuesday, show me all the changes in my environment plus or minus an hour from that time. That configuration data is going to be extremely useful for that. From a modeling-based perspective, again, investigations and similar threat detection, pretty poor, and I would say even scoping poor. Basically, it doesn't have enough transparency to be useful for investigations. You're effectively saying, here's an alert, now go figure it out. But it is really, really good at novel attack detection because, again, you're not detecting off the individual threat. You're detecting off changes in your environment. And that's one of the biggest kind of value propositions of anomaly detection for threat detection. We've got other value propositions effectively related to like misconfigured devices and answering non-security based questions. I think that's even stronger there. If your use cases end up being not security, but more of changes in your environment, that's effectively really good. From an indicator-based perspective, I'd say really the main use case of indicators that I see is enrichment and scoping. Once I know that the VPN into my HMI, the dropped a file and RDP'd out is malicious, then whatever the IP addresses were and whatever the digital hash was, I could take those and scope my environment quickly to figure out where else I've seen that in my environment. And then from a threat behavior perspective, it's not as easy in scoping. It's really about detection. So indicators are better for scoping, but it's really, really good, actually the best at detecting similar threats. So even though the attacker might be different, the malware might be different, the vulnerability might be different, the way the attack was done was similar. So it's really good at that. And it's really good for investigations because it has enough context to be useful for things like security operations, incident response. But it's only so-so at detecting novel attacks. I'd say the way that you can get threat behaviors to detect novel attacks is having analytical coverage, which is kind of what Sergio was talking about in the beginning, where he said, look, I've got detection across different stages of the adversary kill chain. So if I think about the Trisis attack in Saudi Arabia, where the modification of the safety system took place, the actual modification of the safety system and how they did that, that was novel. Anybody that comes out and said, oh, we could detect that, I think that's very misleading. You wouldn't have detected it. I mean, you could have an alert, but I wouldn't call every alert a detection. But it was novel. But the lateral movement from the HMI to the engineering workstation, the modification of the engineering workstation, the compromising of the vendor VPN into the environment, none of those things were novel. And so with proper analytical coverage, you would have had a detection and depth strategy to be able to detect that before the attack occurred. But it is fair to say the actual, that single step would have been novel, and you would have had a threat behavior for that. Next. And so with that, I'm going to turn it back over to Sergio to end our session out with going through an actual use case across an industrial environment, and then we'll open it up with a couple minutes for questions.
Thank you, Rob. Yeah, so I'm going to just quickly roll up here for some mental juices here to kind of talk through how you might think through your detection strategy against the specific threat that you're concerned about. So a very common method of getting into an OT environment is to start in the traditional IT business networks. And so here we have an engineer that has a very nice, very strong LinkedIn profile, as many do, who gets a spear phishing email, and then that spear phishing email produces a keylogger and a remote access Trojan. Of course, the engineer is going to log into the OT environment from their workstation. Probably it can either be through a VPN or a jump host or however you have it. But they're going to log in, and the keylogger is probably going to grab whatever credentials are being used. So that's how we're going to start in IT land. And now let's move into the OT space. So now what we're going to do is the adversary has the VPN credentials. And they're going to just VPN straight in. They can come through the business network at this point, or they can come out, of course, through their own IP space, depending on what they want to do. And here we have a couple of choices, right? We can do. There's a lot of really good user entity behavioral analytics that can be applied to VPN logs and authentication logging, and so we can find certain things, at that level. We could do IP whitelisting, right? So that's going to be a configuration type of detection and control, right? So at that point, the adversary may have to come through the business network, right? Which gives us maybe an additional way of finding them. And so that's good. We might have a known adversary IP address that they're leveraging, right? And so that could be an indicator we could use. Again, these are things we could all look for at that level. The next step is they're going to drop through the VPN into an engineering workstation, bring a file with them that's going to do some fun things. They're going to, first of all, that engineer is really nice to list all of his years of expertise doing ABB and Rockwell controllers. And so, now we're just going to start looking for, port TCP port 44818, which is a common ABB and Rockwell controller access port, and we're going to just scan the environment and start looking for controllers. Now, this is an interesting behavior, right? Scanning activity is fascinating. So maybe we can look for network model detection, right? So we can look for unusual network activity and scanning, one engineering workstation talking to many controllers in a very short period of time. We can look for behaviors, right? So here is, again, you can also do behavioral detection here and say, well, multiple, sockets being opened at the host, or we can say looking at the network traffic, multiple TCP sessions being initiated. So we can look for behaviors that way. We can do things like maybe we know the known file hash that the adversary is using. So we can take an indicator-based approach. So these are all very important, right? So next, the scaling of OPC servers, right? So now he wants, this adversary, he or she wants to find OPC servers in the environment. So we'll do an OPC scan and we'll enumerate the OPC servers. Again, we could either do things on the engineering workstation, finding this behavior. We could be on the OPC server. We can look on the network, when and where and why you're looking for these things. That all feed into why you're doing what you do and the type of results you're going to have to being able to find this stuff effectively. So the next step, right, there's just 2 more steps here. The next step, they're going to write some values to the, overwrite the OPC server values. And in one case, we know that they've been writing the out of bounds value to OPC servers. And that's fascinating, right? So from a configuration perspective, maybe we should never have engineering workstations writing, out of bounds values to OPC servers, right? That's one potential policy in an environment. Maybe another policy or behavioral detection is that, not all the OPC servers should be attempted to be written to at the same time. That might be a really good policy to have in your environment and a good behavior or configuration detection. Again, like you can look at these, and so I strongly recommend looking at the threats and your assets from different perspectives, right? From indicators, from behaviors, from the network, from the host, and really kind of think through how and why you're going to be looking for things. And then lastly, now that engineering workstation is going to attempt to overwrite values on the controllers themselves. And again, we could say this is a configuration problem, right? This is unscheduled controller change. And we're outside of a maintenance window. We could do behavioral detection, right, again here, and say, well, this engineering workstation shouldn't be doing this to controllers. Or that's an unusual behavior to be overriding, maybe we do behaviors of certain protocols, and we're like, well, that's an odd thing to be doing here. So these are all methods of madness, as you will, to getting to behavior. But going back to what Rob said, the key is to line up, right, your assets, the behaviors and threats that you're looking for, and most importantly, to line up the costs and benefits of taking different approaches to finding this, right? So do I care about finding every new file on a engineering workstation? Probably not, right? I don't want to create a detection for every new file on a workstation. That's, in many environments that will just be probably stupid, right? But is it good to log that, right? And maybe not generate an alert, but generate some sort of detective log to say, yeah, that would be nice, because then if we knew we had a problem, we could go back and say, oh, and there was a new file created. Oh, and there was a new network socket established, with these things. So sometimes think of detection not just in terms of alerting, but also in terms of logging and generating some sort of case file that you can support. So next. So to finish up, as I just kind of kind of just talked through it, we have 4 major types of detection: modeling, configuration, threat behaviors and indicators. Utilize all of your detection methods. Threat behaviors are really powerful. I highly recommend, a lot of people have put a lot of energy into modeling, configuration, analysis, and indicators over the last decade. I highly recommend, though, especially as the MITRE work has shown, as Rob pointed out, that we can think through adversary behaviors now in a new way. And so I highly recommend that you start thinking of your environments in that way as well, not just in terms of the other 3 that you may be more used to. And detection, and recognize how detection is multi-use, right? How, when, where, why are all important questions to ask about detection. It's not just about the box you're plugging in or the software you're installing, the agents you're installing, or what you've got running right where. And we walked through how you generate a detection strategy, right? So generate your detection targets. What are you trying to find? Where are you trying to find them? How are you going to try to find them? Why are you trying to find them? Create your analytics map. Even if it's not good, it's a great way to start thinking through this problem and finding some gaps. And then implement your plan using the costs and benefits of each type, right? So maybe modeling fits here, but threat behavior works really well here. And so let's focus on implementing those. And then finally, test and measure your coverage. Like I said, you could go with a red team approach, a blue team approach, and unfortunately also, but very strongly also use your actual detections and adversaries that you may find on your environment to help you understand your own good and bad parts of your own detection. That's a critical element as well. Okay, so I guess with that, I guess we'll have we can have a few minutes for questions.
Yeah, absolutely. So I see over the right, we got a couple questions. I'm gonna take just a few and then we'll go ahead and end it out for everybody, but appreciate everybody's paying attention. For those of you that won't stick around for the questions, just know the webcast is recorded and so it'll be available on the Dragos site after, probably like in the next day or so after today. Cool. So one of the first questions is a good one. We kind of touched on it, but it's still an important one, which says, threat behaviors, aren't they effectively after the fact? Like, don't we need to be thinking about threat behaviors after something occurs? Yeah, absolutely. So I think it sounds really backwards and kind of how you approach it, because you're like, well, it's an after the fact. I want to be proactive, but the reality is it's after the fact for that type of activity. A lot of, actually most security teams around the world struggle with detecting similar style attacks. So it's actually a proactive approach, but you're looking for behaviors of adversaries versus just behaviors of your systems. So yes, the novel attack might occur somewhere, but think of it in IT security as an example. How many attacks effectively follow the behavior of an inbound email with an attachment that once the attachment runs, code is dropped to the system and beacons out? I just described like 70% of phishing emails, right? But that's one behavior you could look for. So it is after the tradecraft is identified, but once you've identified tradecraft, it is extremely durable and transposable. So it's you're looking at it across lots of different adversaries, lots of different capabilities, lots of different victim sites. It's still a good question. I think, as I approached it and kind of how I talk to the industrial community anyways, I think vendors, and we're probably at fault for this too, but I think just anybody that gets passionate about their approach and what resonates with them, really, really champion that approach. And sometimes it can lead to like the silver bullet kind of feeling from vendors where they say, oh, if you just did this one thing, it'll be fine. And even though we don't do anomaly detection, like we're not modeling like our technology as an example, we don't do that. We focus on threat behaviors. I'll be the first to admit that you should do everything. Like I think there's an order and there's a structure and there's a way to get a better result, but you should have a layered detection strategy. I don't think there is a one-based approach. So as an example, if I can think about if I can either see from intelligence the types of behaviors that I need to be prepared for, or I can think about the types of attacks that could happen in my environment, I should cover those down. Like I shouldn't be waiting for some random anomaly to occur and then try to piece together the events to equal that answer. If I already know what I care about to start with, I should look for those to start with. That's kind of that threat behavior approach. That doesn't mean that once I'm done or once I've exhausted that I shouldn't also be looking for random things in the environment to go investigate or maybe hunt through and be looking for novel things that detection's not picking up. So I think there is a proper order, and I would argue with anybody that says kind of that it doesn't matter what detection type you get as long as you achieve the same result. Yeah, it really does. It matters a lot, and the effectiveness, the efficiency, how many people it takes, different data sources you need. I mean, it has a huge impact. But I do think you should do them all. I just think picking a strategy and understanding the pros and cons is an important thing to do. For my view of the world, I would do a threat behavior based approach to start with, extend it with modeling and configuration, and then as I identify indicators relevant to me, scope in my environment to be able to look for those. But anyways, that's one approach. And then Sergio, if you have any thoughts on this, another question we had, we'll take this one as the last question because I know we've exhausted everybody's time here. But it really talked about like metrics. And so the question goes to, what general metrics do you suggest from like a SOC detection quality? We kind of covered a little bit around like transparency and adaptability and so forth, but like what are some decent, SOC metrics, especially incorporating like industrial networks and how we think about what defenders should be doing and how they should be measuring themselves. And he specifically calls out SOC CNN project, or more specifics and updated thinking and like MITRE ATT&CK, or CAR or detection maturity model? Effectively, how should we think about measuring our successes instead of just being bound to incident response?
Yeah, that is a great question, and my recommendation is that that there's the standard security operations model, allows you to think through the different parts of how this works. And so I recommend that a couple of key metrics here to consider to help improve your detection quality. First, to identify if you have a problem, and then, of course, identify where you can make improvements, is going to be one is time to triage, right? Is a huge deal. It's one that I find a lot of organizations don't track very well. They may track it, but they don't. I don't know. They don't really think it through, from what I've seen. So, really a big challenge is going to be when an alert hits. The fact is, how long does it take your analysts to figure out if that's, one, real or not real, and two, what you should do about it? And finally, the second metric that a lot of people don't think through is, the qualification of that, right? So there's a quantity approach, right, which is, well, how long did it take? And then there's a qualification, right, which is, well, was that actually the right answer? How many times did we do something and get it wrong? How many times did we triage something, but that triage was incorrect, or the analyst felt like they didn't have enough data, right? Did they ever have a choice to say, oh man, this would be awesome, but I got to close this ticket, but it really was, but I don't feel like I was able to do a good enough job here and I needed more. That's a really big deal. Then when you get down further, past like level 1 and into level 2 and level 3 SOC response, and now the question's going to be, well, how easy was it to implement new changes to detection? That's a great question for maturity. Can we implement detection really quick? If we had an incident and we needed to scope it real fast, great, I could get an IP address out, into my SIEM, and I could search, my operations data really fast. But if I needed to know something about, my processes, is my process safe? Is something going on? My question is going to be, well, how quick can I scope it, right? How quick could I get something out to query this data and to figure it out and find out if it's continuing, right? Not just the question of, well, is it going on in the past, but is it going on in the future? And as we move forward. So I think those are really two areas that I'd love to see people move, get better at in terms of metrics and measuring.
Yeah, fantastic. And then as we close it out, I'd recommend, especially on that topic, we've published 2 white papers recently outside the Vortex detection paper. The first one was done to date, which is collection management frameworks, effectively what data you have in your environment and how to think through like what your data is giving you, and effectively taking an asset inventory and extending it to being able to answer questions. And the second was a paper written by Dan Gunter and Mark Seitz, 2 of our threat hunters. They published it at the SANS Reading Room, but I think it's hosted on our website as well. And it's around a threat hunting model. And one way to think through metrics and around like your detection strategy is effectively to test it. It's to look at your coverage. And across the CMF paper, the collection management framework, and across that threat hunting paper, you could effectively think about the types of attacks you want to be able to detect and how you want to be able to be prepared, or look at the attacks that are getting documented externally to your company and do an assessment across your environment, which is really what a threat hunt is, of let me go try to find the threat, but let me be looking for whether or not we could even detect it. You should be able to answer that question. You should have enough coverage and insight and visibility to be able to say, would we be able to detect and respond to that type of attack? And then figuring out your detection strategy against that to determine how whether or not you could, and being able to report good metrics back to your teams or your execs on saying, look, we invested in people processing technology in these areas, which really led to our invisibility improvements, led to our detection improvements, and we can now reliably say that we feel confident or comfortable being able to detect and respond to these types of scenarios that drive risk to the organization. Like that overall is effectively a really good stance to be able to take, and also show that return on investment in security. But anyways, with that, we'll go ahead and exit it out again. Thank you for attending today, and look forward to chatting in the future. Take care, everybody.